welcome back to the Rabbit ECU project. I just wanted to show you here some new hardware. It's our latest and greatest hardware for the Rabbit ECU project. And this hardware goes into the Rabbit ECU RG1, which is the ECU we developed to run the EA888 engine. So if you've been following the Rabbit ECU project, you're probably reasonably familiar with this board. This is the main motherboard that we've been using since 2017, and very little has changed on this board, even though we're up to version 1.5 now. We're using the same Molex 80-pin connector, which gives us a bunch of I/O options. The only real main change from earlier versions is the addition of these two motor driver chips. So now that we have 8 channels of push-pull motor driver output on the main board, but typically they're used for igniter outputs to signal coil-on plugs. So on this board you can run a V8 with coil-on plug ignition, and also another feature of the 1.5 is the ability to run 8-cylinder sequential injection as well. So there's 8 port fuel injector drivers on this main board. So the real addition for the RG1 is the addition of this board, the SparkDog PFDI board. And this board, in conjunction with this new board here that you see, which is a voltage booster circuit, gives you the ability to run 4 GDI injectors. So you can see on this board, these are the MOSFETs for the high side drivers. There's 4 of those, 1 for each cylinder on the positives of the GDI injectors. And the GDI injectors are multiplex, which is the typical OEM way of running them. So we only need 2 low side drivers for those 4 injectors. Some other nice features of this board is these solenoid drivers on the underside of the board. And that gives us a total of 8 solenoid drivers that you get in addition when you run the PFDI board. So that's good for, say, quad variable valve timing V8, where you need quite a lot of extra drivers to run the phaser solenoids. You can also see there's an NXP micro on this board as well. So that's 3 NXP micros in the RG1. And that gives you a total of 230 megahertz of MIPS effectively. Also on this board is this push-pull motor driver circuit for running electronic throttle control. And we're also working on some software that gives you the ability to use this hardware and a few other drivers on this board to give you an additional 7 injector driver outputs on top of the 8 on this main board. So up to 15 port fuel injector drivers potentially on the RG1. And this is what the enclosure looks like. Once you put all these together, this is a plug and play. So yeah, we're running the 80-pin Molex connector. This is a tough black anodized aluminium enclosure. And you might be able to see there, it has a USB mini connection exposed. So one final thing to mention about the PFDI board is that it is plug and play, even with the older versions of the motherboard. And it's just simply a matter of popping that on top there. I'm not going to engage it right now, but you can see that that's basically how the ECU is constructed. And then that whole assembly will slide inside the anodized enclosure here. Thanks for watching, and I hope you can stick around for the next section, which is talking about the software development. So we're looking at the logic signals here that are coming out of the Rabbit ECU and also into the Rabbit ECU. And the top 4 signals that we're looking at here, you can probably guess, are the igniter signals. So with the EA888, we're running coil-on plug ignition, which means 4 channels of sequential ignition signals. And with the Rabbit ECU, there's also possibility to expand out to 8 cylinders. So you can run coil and plug, fully sequential ignition on an 8-cylinder engine as well. So moving down to the next couple of signals, you can see the cam sensor signal and also the 60-2 crank sensor signal here. So by virtue of the fact that we run a pretty fast micro that's running at 120 megahertz, that gives us the ability to schedule off every single tooth that comes in on the crank sensor. And because they're 6 degrees apart, you can imagine that gives us the ability to schedule really accurate ignition timing and also the kind of really accurate fuel injection timing that we need for GDI. So moving down to the bottom couple of signals, you're looking at the GDI signals on the low side driver. And you'll notice that this is not just a simple on-off signal, it's a PWM mode signal that allows us to modulate the hold current of the GDI injector to an appropriate amount. So I can run this thing up to, say, 6,000 RPM there. And you can see that all of the signals are very stable and accurate. Just going back to the fact that we're running a 60-2 crank sensor. And yeah, you can see the multiplex GDI signals down the bottom. So over the cycle, you can see these GDI low side actually fires on every revolution of the engine. And the way it works is that every second firing of the GDI low side goes to a particular cylinder, and the opposite firing goes to its opposite cylinder pair. So in that way, the GDI low side is multiplex just to save on hardware. So guys, you're looking at the test engine here, fitted to a Toyota Crown Majesta 2013. You'll also find this engine in cars such as the LS 460, the Lexus. So the technical name for the engine is 1UR FSE. It's a Toyota V8, capacity 4.6 litres, and also it's an over-square engine, so likes to rev, and the peak power of 385 horsepower comes in at 6,400 RPM. There's an awful lot going on, as you can see here under the bonnet. This engine has electronic throttle control. You can see the GDI injector driver box is sitting on the top there. So we're running 8 GDI injectors along with 8 port fuel injectors. In addition to that, this is a quad variable cam engine, so you're also going to need to run 4 camshaft phaser position sensors and also the 4 position solenoids to go along with that. So yeah, there's an awful lot going on under here. I suspect the way to run this thing with the Rabbit ECU is to actually run 2 Rabbit ECUs. So yeah, you might be thinking that sounds a bit crazy, but it is actually done in OEM land. It's a thing that happens. Lots of ECUs are capable of running 4 GDI injectors, but there's not so many that are capable of running 8. So I think that's probably the way to go here. Have a couple of Rabbit ECUs running in parallel to be able to handle all the I/O that we need for this project.